Hello again, I'm Jeff, this is Thinking Maths, and welcome to my video on the power of a product and power of a quotient rule. Now I'm doing both videos in one because as thinking principle number 1 says, concepts in math repeat themselves. And you'll see that when we work with multiplication and what we do with that product rule and what we do with the quotient rule, they're very similar process you've seen in the past, so I'm going to introduce them all at once. So let's take a look. So on the board here I have both my power of a product and power of a quotient rule. And why I introduce them at the same time is because how we use these laws are very similar, again because multiplication and division are so very similar. So in the first one I have two bases multiplied to another power. And you can see that when that's the situation, I essentially just distribute that m, so to speak, as an exponent to each of these bases, and I get a to the m times b to the m. And that's the exact same thing as in the quotient rule. I can take that m and distribute to the numerator and denominator, and I get a to the m over b to the m. Now a numerical example of that is as follows. I could have 3 times 4 squared. Now according to BEDMAS, in the brackets, I can go 3 times 4, which is 12, and squared is 144. But this product rule also applies, and it's not, obviously, you're not going to use this when you see numbers in this situation, but it's great for algebra, so it's good to see it this way as well. I can apply this law here and distribute the 2 to each of those, and I get 3 squared times 4 squared, which is 9 times 16, which obviously is also 144. And it works for division as well. I can have 12 over 3 squared. Again, BEDMAS, 12 divided by 3 is 4, 4 squared is 16, or I could also write it as 12 squared over 3 squared as I distribute that square to both the numerator and denominator. And I get 144 over 9, which is 16. So now, hopefully you have a better understanding of the law. Let's take a look at some numerical examples. Okay, in this first example, I have 5a cubed squared. Now, just the a is cubed. I see some students struggle thinking 5a is cubed in this situation. No, just the a is cubed. Then I have that whole base of 5a cubed to the power of 2. Now I can treat my 5 as my a value and my a cubed as my b value. When I apply this law, I take the 2 to the 5 and 2 to the a cubed, so it looks like 5 squared times a cubed squared. Now, if you recall from our power of a power rule, whenever I have an exponent to a higher power, I end up multiplying them. So it's really a to the power of 3 times 2, which gives me 25a to the 6th. The next example here is a quotient rule. Again, I have 1, 2, 3, 4 terms, and because I'm dividing to a higher power, I'm going to take that 2 to each of the 4 terms. So I get 3 squared times x squared to the power of 2. Again, I just took that 2 to both terms on the top. And I do the same thing on the bottom. 5 squared, and I get y cubed to the power of 2. Applying that power of a power rule again. 3 squared is 9. When I have a power to a power, I multiply. 2 times 2 gives me x to the 4th. And then 5 squared is 25. And then again, I'm multiplying these exponents here because it's a power of a power law. 3 times 2 is 6. I get y to the power of 6. Now this last example here, I threw a couple tricks into it. I have a negative exponent, I have a fractional exponent, but it does not matter. Okay, I follow my thinking principles that say focus on the concept regardless of the numbers being used, and I'm multiplying a d times an e times an f to a higher power, so I just apply this law here. If I take the 2 to each of these, regardless of their numbers, I get d to the 6, and then squared times e to the negative 3 squared times f to the 5/3 squared. Now I apply my power of a power rule and I multiply. So 6 times 2 is 12. Negative 3 times 2 is negative 6. And then f, 5/3 times 2 is just 10/3. Now maybe your teacher will ask for positive exponents, and if that's the case, all you would have to do is drop that e to the 6 to the bottom to make it positive, as outlined in the negative exponent video. But your answer ends up to being d to the 12th, f to the 10/3. e to the negative 6 or over e to the 6. Doesn't matter which is which. So that's the power of a product and power of a quotient rule. Keep watching for more videos on the exponent laws.